Yes.
Hello, ma'am. I welcome you to my podcast. I'm really thankful that you gave me time to come for this podcast.
Thank you. Thank you for inviting me.
So, for the audience, just tell them about yourself, who you are, and what you do.
Okay. My name is Rupal Srivastava. I recently completed my PhD from IIT Kanpur, and I did my PhD in solid mechanics and design from the Department of Mechanical Engineering. After that, I joined the Confirm Research Manufacturing. It's a SFI funded lab. SFI is the Science Foundation Ireland, and as a postdoc. And there I'm working on smart wearables. Here in PhD, I worked on smart composites. That's where I got the idea about smart materials, their applications in various fields, various domains. And through that, I got the idea for my postdoc, for the proposal. And that's how I'm working on smart wearables now. So these are my fields of study: smart composites, cobotics, human-robot interaction, things like that.
Wow, that's great. That's great. So, I'll just go a little bit into from where you started, right? So
Mhm.
I know this thing is changing as of now, but a girl taking mechanical stream is still a taboo, and your BTech is from mechanical stream. So
Mhm.
did you also faced these kind of things in during your BTech, and how you coped up with all of those?
Uh, I would say that I have been relatively, not completely, but relatively blessed in this field. I did face some bias here and there, but it wasn't as much that it would take, a toll on me, or it would hamper my work.
Mm-hmm.
So, for example, it's there in a very subtle way that
Mm-hmm.
there is kind of bias,
Mm-hmm.
but it's not very evident. But somehow it does become, because I remember that in my first year, you know that in BTech you have to take workshops. So I
Mm-hmm.
was taking the carpentry workshop, and the supervisor or the teacher or the professor there, he said, no, the girls, you just sit, you don't need to do that because it's a boy's job. So, and how did I cope with that was that I did exactly the opposite. I just said, no, we are taking the course. We have to do it because it's a part of the experience. So we just got up and we started to do. And I'm not saying that it's not relatively tough for girls. It is, because we are not built heavily or, stronger in the upper body. But, it's the trick of it. It's the trick. If you get the hold of the trick, you can do any job actually, and practice. So we did all the workshops, fine. I mean, all the girls were doing carpentry, we were doing welding, we were doing molding, all the workshops. So the solution to bias is you do exactly the opposite. What you're told that you cannot do, you do that, because not to prove anything, but because it's a part of the experience. You are becoming an engineer. You're not becoming a female engineer, right?
Mm-hmm.
So in order to become a professional, you have to have a gender neutral environment, and it starts with you. You have to create that. And it's not a fight, I mean, with the professor. It's just that maybe they're not aware that,
Mm-hmm.
the girls who are coming in these days, they are interested in this. So, it's not that you are against them. It's just that you have to show them, and you have to tell them that, yes, let us have this experience, or treat us equally. And they would eventually will, because they are not there to be against you. They are there to teach you.
Mm-hmm.
And still in India, there is a bias, but the solution is to be more considerate about that, because, the society you're coming from, it's slowly changing, and gradually you will see the change, and you have to be a part of the solution.
Mm-hmm.
And the solution is that you show them in a very polite manner that let's change together.
Mm-hmm.
And I remember then, this was my first year, and then in fourth year, I mean, everyone would ask me, what's your plan after BTech? And I said, I want to go for masters. And there was this supervisor, he said, again, sorry, I'm in the habit of saying supervisor, but a professor who said, why masters? You should just get a job, get married. Why do you want to go, masters? And then I did exactly the opposite. I went for my masters. So the thing is not to be angry with these things, but to remember, you forgive, but you don't forget. And that's how you continue in this field as a woman, because then there are subtle things which will come throughout your journey, starting back from BTech to completing my PhD, to not yet in postdoc. It's just been 6 months, but there will be experiences like this where people will try to not stop you, but they won't understand your passion. They won't understand what a what an engineer should be. They will think that she's a female engineer, but there is no such thing. So the solution is to just move on and to avoid these things and to change together. So that's what I would say. That's how I coped.
That's so good to hear. That's so good to hear. Because I would like if many more girls do the same thing that you are doing. Because it really takes a lot of efforts to go opposite to what everybody is saying to you. And I can understand how you have been facing all of those things. So I totally get it, and I really appreciate that. So
Thank you.
as you said that after your BTech you did your masters. So would you like to share about what was your research work during your masters?
Yeah. So the first year is the coursework, and in the second year you have to take up your thesis. And in that, what I did was that I analyzed beams. So there are two basic beam theories. One is the Timoshenko beam theory, and other is the Euler-Bernoulli beam theory. So what I did was that I compared the two theories for the transverse analysis of the beam. So the bending, the vibration modes, how are the two theories giving us different results? Because as you know that in Euler-Bernoulli beam theory, the assumption is that the mid-plane remains perpendicular even after bending. But in Timoshenko beam theory, you assume that no, it's also bending, which is the more accurate version. So I did this analysis in ANSYS and in MATLAB, and I compared. So I validated the data against each other, what I'm getting through simulation and what I'm getting through the FEM modeling. So that was my work there. And while I'm talking about this, I would also like to acknowledge my supervisor, Dr. Shankha Baduri, who passed away due to Corona last year. And he was an amazing person. He was very understanding, very cooperative. And sometimes I would feel that I would go to him with a problem in the code, and he would just leave the code with me, and he would just kind of do something and it would start working. So he was very understanding. He never said, no, you should go and figure it out yourself. He did give us support data like reference documents, but he never would bully us or, say things that would demotivate us. And I remember that he was the first person that I called to tell that I got my PhD in IT Kanpur. He was very supportive and very encouraging person. So yeah, sorry for bringing that up, but it was important. Yeah, so that was my master's research work.
Because it's really, guides do have an actual role to play when it comes to research. But there are every type of guide in this world. Some do support, some don't. So it's totally fine. And I really feel good when I hear the stories of a guide who does. Because I tell you, my master's guide and my PhD guide are so good. Are so helpful. But sometimes when I hear stories of those who are not, and I'm like, okay, how is this happening?
Yeah.
So I
Yes.
get that point. I get that point. So after your masters, you just went to the IIT Kanpur. Yeah, and during your PhD at IIT Kanpur, you were a visiting scholar at Kyushu Institute of Technology at Japan. So if you can tell us something about how that experience was.
Okay, so just to fill in the gap, I didn't go directly from my master's to my PhD. I took a 6-month break because,
Okay.
the written examination and the interviews of IIT Kanpur for PhD, they take a little bit of preparation. So I took that break and I was living with my friend. She lived in Bangalore. So I just went there and I stayed there and I took the weekend coaching classes for a month or so. In 6 months, I thought that, okay, for the revision part, in the end, I will take some classes. So in 6 months, I took 1 month of weekend coaching classes. So around 8 coaching classes, and I stayed at home and I prepared. So it's okay to take a break. So that's the message that I'm also trying to put across. And then I went to IIT Kanpur. And so again, the most important part of your research is your supervisor, especially during master's and PhD. And in IIT Kanpur, once you reach there, you have to choose your supervisor. Okay, so you are given some time. For example, let's say a month or 6 months, depends upon which batch you are. So because I completed my master's in summer, I joined in winter, so I was a winter batch in IIT Kanpur, and we were given a few weeks. I don't remember exactly how many weeks to choose our supervisor. And I looked up what the supervisors were doing, and I saw Dr. Bishal Bhattacharya, and his thesis was on FEM of composites, smart composites. And because I just came out of FEM of beams, I thought, okay, now from beams I can move to plates because it was on composites and plates. So I thought that, okay, it's very relevant to what I have been working on. And also because I was very impressed by his persona. He was very happy all the time. He was in the interview panel when I gave my interview. And he was the only person who was smiling all the time and drinking his tea, and it felt very comfortable. So it wasn't just his research, but the way he was treating his students. And then I also saw that he had many projects with him. He had projects from ISRO, from Gale, and other small companies and industrial projects. So, and two ISRO projects at the time, I remember. So it was very impressive for me because ISRO for us is a dream. And that's when I joined him. And it was through him that I was able to get the Sakura Fellowship. That's how it happened. So he had a collaboration with Professor Wagatsuma at Kyushu Institute of Technology, and he works on brain science. And there was an exchange program. So what happens for Sakura is that you should have a certain amount of CPI, and then you are selected for the program. And because we were aware of these things, and because there was already a professor who was going to accept us in his lab, it became a little bit easier for us that, okay, we already have a professor, we just have to present our CV and then do the formalities. So yeah, so that's how it happened. And then I went to that institute and carried out my research for 1 month. And these days it's a bit different. There is also a written exam. So you have to give the written exam if you're in the top 5 or things like that. Then because ours was an initial batch, so we were the few students. And now the competition, as it becomes more and more, I wouldn't say popular, but there is more exposure to it. People, they get interested and there are more applications. So now it's much tough than it was in my time, unfortunately, but that's how it happened. And yeah, so I went there and I worked on EEG Control Robots. So you're taking data through EEG, and we were then triggering different motions in the robot that we had. So that's how we worked there. It was a 1 month project. It was really good.
So as you were speaking, you mentioned about a thing called as CPI, right? So what is that? Because I don't know about it.
Okay, so it's just that you have broken down the grades A, B, C, D, E, F into numbers. So A is 10, then B is 8. Yeah, and then C is 6, and then D is 4, and then F is fail. So that's how it is. But so it's how does someone get, let's say, 8.5 or 9.5? It's an average. So if you got an A, you have a 10, then you got B in 2 subjects, you have an 8 and 8, and then you get an average of what your CPI is. So you have a CPI and then you have SDPI. So it's the average of all the semesters you have already taken.
Okay, so you're talking about the grading of all the semesters. So that is what they see when they select somebody for a visiting scholar. Okay. So,
yes, and
please speak. Yes, please.
Yeah. So depending upon the number of courses, you can also improve your CPI or yeah.
So what is actually a visiting scholar?
Okay, so you are invited or you apply and you are accepted. Yeah. In a project which is relevant to your field, and you can work there for, let's say, 1 month or 2 months, depends upon how much funding they are providing. And you have to complete a small project, like a short-term project, and you are free to use all the lab facilities at that institute where you are invited. So that's the host institution. And there has to be, not necessarily, but could be a collaboration between the parent institution, which is where you are studying, and the host institution where you are going to do your research work. And what you can do is that you can take that research work and also add it to your thesis, or if you are in BTech, because BTech students also do their visiting scholar research projects. So you can add it to your BTech final year project. So that's what they do. So, and the funding could be in many ways. Like for us, it was also a stipend. So we were also paid. And then our housing was paid for. It was already paid. And our food was also paid for. So the food was already paid. And on top of that, we got stipend. So that's how it was possible for us to sustain ourselves.
Oh, that's great. So this brings me to very very basic question that anybody will have when they listen to all of this. So if
Mhm.
I'll talk about the process of becoming a wasting scholar. So as far as
Mhm.
I can understood, there are two ways. One is when we apply for it. The forms come
Yes.
out,
Mhm.
we apply for it, we give the exams and all that stuff. The second is when your guide or your supervisor recommends you to add some institute. So are
Mhm.
these two ways only, or is there something other way also?
There are other ways. A third way is that you approach a professor that
Mm-hmm.
my research is on this and you are working on this and we can both collaborate and you
Mm-hmm.
will benefit from my research in this way and I will benefit from your lab in this way.
Mm-hmm.
And then if he accepts, what you can do is that you can apply. So DST and SERB, they have many funding opportunities where you can go and search where they pay you to visit other universities. So they are funding a scholar to become better so that they can come back and then, work better in the country because they will be making use of their infrastructure, their lab facilities. So there are
Mm-hmm.
many fellowships
Mm-hmm.
provided by the government which you
Mm-hmm.
can apply for after you are accepted because they will take that, okay, where is the letter of acceptance? And
Mm-hmm.
so these are some fellowships which are available almost all year around. And then there are some specific fellowships that come out because I remember one is called the Indo-US Women in STEM Fellowship. And it's specifically for women.
Mm-hmm.
There are many for men as well, like as in common fellowships. This one is specifically for women where a PhD student can find a supervisor in America and then if they have accepted, if they have a letter, they can write a proposal and then submit it to the agency. It
Mm-hmm.
opens every year and it's a 3 month, I suppose, 3 to 6 months fellowship that you
Mm-hmm.
can get. So apart from these fellowships that you can look for, which are available all year around, there are some specific fellowships to better the what do you call it, academic relations between the two countries. So there
Mm-hmm.
will be an Indo-US fellowship, some Indo-UK fellowship. Some would be with 3 countries like Indo, UK, US fellowship with Norway, Sweden, Finland. So there are many fellowships like these as well, where students can go and look what are the requirements if I'm eligible, and
Mm-hmm.
then look for a professor in that specific country
Mm-hmm.
and then they can continue with the fellowship. But again, in almost all these fellowships your supervisor has to be on board because their signature is a must. So you
Mm-hmm.
should discuss it with your supervisor once before,
Mm-hmm.
then you can go ahead with this. So there are 3 ways.
Mm-hmm.
Like
Okay.
if the institute has a personal fund,
Mm-hmm.
then your supervisor has a relation, then you can go. Second
Mm-hmm.
is through how you apply
Mm-hmm.
to special fellowships, and then
Mm-hmm.
third one is that you find any professor anywhere and then apply for a funding.
Got it. Got it. Okay, so as we were talking about your journey as a visiting scholar, so during your PhD, you were also part of ISRO, in Indian Space Research Organization. So if you would like to share with us what was your work there and how was the working in environment of ISRO?
So I worked on an ISRO project. So the project was there in my lab, and when I got there, I discussed the various topics. So you have to discuss what your thesis is going to be on. So I discussed it with my supervisor, and this was a topic that we both found very interesting. And so it was an ISRO funded project, and we had to go to ISRO for the review of the progress. So that's how we used to visit. I did not work in the ISRO lab itself, and it was in SAT, Space Application Center in Ahmedabad. So that's where we had to go for our review reports and for seminars, workshops, some things like that. And the project was on Gossamer structures, and these were
Mm-hmm.
space inflatable structures
Mm-hmm.
where you can have, let's say, an antenna in space which is inflatable.
Mm-hmm.
And the reason why we need these structures is to reduce the payload costs. And as light the payload is, the least expensive it becomes.
Mm-hmm.
So the idea behind inflatable structures is that you can have tightly packed stored volumes. So they would be very small, let's say 1 meter cube, small boxes that you can just put on the um, on the on the I forgot the term. Okay,
on
so you
that
can
spacecraft.
take it into space, yeah, and then you can deploy it in space. And once you deploy it, they become like huge, let's say a house-sized antenna or something like that. So the concept behind that is to reduce the overall cost of the program.
Okay.
And that's what ISRO was working at the time. That
Mm.
a similar project was done by NASA in the 90s, and it was successful in some manners, but in many ways it had many challenges and disadvantages. And while we were working on the project, that's how I figured out what my thesis would be. How to reduce those challenges, how to replace inflation by other methods of deployment and rigidization. So deployment is taking into space and then deploying it into structure. Usually what they do is that they inflate. So there is a gas-based inflation. But there are many issues. For example, if it's a membrane structure and you have inflated it with gas, there are many space debris which can attack, and then there will be a wear and there could be a leakage and there will be a system failure. Also because inflation is not controlled. So when you inflate, even let's say a small balloon, it's quite controlled, but when it's a larger structure, it's very uncontrolled how it's going to inflate. You cannot control the process. So these things are not good for a structure, because if it's inflated in some parts and not in the other, there will be a huge vibration, and it cannot be controlled in space because there is no friction. So there were many issues with that project, and we were working on a method which can remove inflation, and we can use some other technology to do that. There are other methods as well, because I saw that at the time there was another girl who did her thesis, and she used electrostatic inflation. My work was to embed shape memory alloy wires inside the membranes, and then to change their shape to make them in the structure that we wanted to have them in. So that was the project, but we didn't go in the labs. We did visit all the labs. We saw things. We don't have pictures of it because it's not allowed, and it's amazing. The facility there, it's just world class. I mean, you go there and then you see how small you are and how huge these projects are.
I get your point.
Yeah, we saw all the facilities, and I remember that there was a facility where you create space conditions inside a chamber, and the chamber is huge. I mean, you just see that and you feel very small in front of these facilities. But we did not work there directly. So that's what ISRO does, is that it kind of outsources small parts of the huge project to different institutions, and you work on a very small part of the huge project. So that's what we worked on.
That's great. So as you talked about inflatable materials, do you think this concept can solve the storage problems of the real world also, in some or
Yes,
the
in
other
fact,
way?
yes, there are many. In fact, there are these structures called tensarity structures. TENSAIRITY, because I'm especially mentioning this spelling because some people write tensarity and you get nothing. You get zero things on Google. So tensarity structures are inflatable structures which you can use for heavy load sustaining foundations. So makeshift bridges, let's say that there was a flood or an earthquake, and now let's say some part of the country is cut off from the main part of the country, and you have to connect that, and you have to take, let's say, tanks and military trucks and whatever you want to take. And then these tensarity structures are just inflatable structures, and they have these wires coiled around these cylindrical tubes, inflated cylindrical tubes, and they're able to withhold such huge amount of load that it gets very easier to make makeshift bridges. And other structures as well, like you can make habitation, and let's say for refugees, you can make habitation very easily. So there are inflatable structures in real world which are solving crucial problems actually. Especially this, it's a really interesting field, and the way it can withhold such huge load and just inflatable structures, it's amazing. It's just amazing.
So for the audience, those who are in their mechanical field, just take this as a research area if you wish to do your PhD, because this has an application and this is solving a real world problem. So it can be done.
Yes, and in fact, in Kanpur, I also went to DRDO. So there is DRDO in Kanpur. They are also having these structures. They do use it, and they are also working on these structures.
So another place to apply for PhD if you want to work in this field. Because I tell you, one of the things that I face so many times, like in the DMs, in the YouTube comments, and somewhere places like this, that what should I work on? Like I seriously don't understand how this can be a question. So it becomes really important if we can just give them ideas about what you can work on, like if we can
Oh,
tell
so
them
these,
about the things about which the work can be done for those who don't have any idea.
uh, so these questions are from PhD students, what to work on,
Sadly
usually.
yes, sadly yes.
I think that the problem here is not with the students. It is with the system that is unable to provide them with exposure. So I never blame the students. I never
i
blame
I also don't.
children.
I also don't.
Yeah. So because there is a lack of exposure, which people like you are trying to kind of cover, that there should be more exposure to these things. So if they listen to more of these podcasts, they are active on Twitter, on LinkedIn, they will surely get ideas of the fields that they can work in. But then they have to go in and read papers to understand in that field, what is the research problem that I can work in. And the research problem can be of two types. One is that there is a gap. Okay, so you can look at the gap, that there is a technological gap which I can fill, or there is development. So there is already an existing solution, but it is not good enough and you want to make it better. So that is the other thing. So these are usually the two things. Like for my PhD, we saw that there is a technological gap. Okay, that we worked on, that there are challenges with the current technology. And for my postdoc, I'm working with smart wearables. We all have smart wearables. We have smart watches, we have smart goggles, some of us. So there are smart wearables, but how can I make it better? How can I make it lightweight? How can I make it sustainable? How can I make its life longer? So these are the two ways that for engineering students, I'm talking about engineering. So these are the two ways you can find a problem. And then for people who are working on the basics, on the foundation, fundamental research, for them, I'm not very experienced to comment on that. For physics and chemistry and things like that. But for engineering, this could be an easier way to find a research problem.
Good. Good. So currently, as you said that currently you're doing your postdoc and you are a postdoc at Confirm as SFI Research Center. So just share us about it, what it is and how you got there.
Okay. So again, now this is for students who are in the middle of their PhD or about to complete their PhD. You have to start making yourself aware of what the future might hold. Do you want to go into academia? Do you want to go into industry? If you want to go into academia, do you want to start teaching right away, or do you want to go for a postdoc? So it's a decision that they have to make. And there are many factors that people have to, count on, like the family requirements, the financial requirements, all these things. And then if all these things allow and you think that, yes, you can go for a postdoc, then you have to start making yourself aware of the various fellowships that are available. Because of the competition in these days, especially during the COVID times, because I applied for my postdoc during Corona in 2020, just when it started, when it was like, oh my God, what's happening? So it was lockdown and things like that. So what happens is that the number of applications just goes high when these kind of situations they occur. So the institute fellowships, they become rare and rare. And mostly the institute fellowships for postdoc, they are filled up with references. Like I have a student in another department, or I know a student. So these fellowships, not fellowships, the institute postdocs, they get filled up in India and abroad as well. But there are fellowships that you can apply for, and you can reach out to a professor, and it goes everywhere, India, ISC, IITs, anywhere or outside you want to apply. You reach out to a professor and you tell that you are interested in their research, you are about to complete your PhD or you have completed your PhD. And if there is a funding, good enough. If not, then can we apply for this fellowship? If we get this fellowship, I will be funded. You don't have to worry about it. I mean, you don't write this in the email, but that's the
That's
sense.
in the mind.
Yes. So you have to become aware about the various fellowships. Unfortunately, when I started applying, only two were left. I mean, the deadlines were over for most of the fellowships. Two were left. One was the Marie Curie postdoc fellowship, and the other one was the Swiss postdoctoral research scholarship. So these were the two Swiss government postdoctoral research scholarship. So these were the two deadlines which were left. So I applied for both of them, and by some luck and situation, I don't know, I got both. So I pursued the Marie Curie Fellowship because it's more prestigious. And I also liked my work there, and so I thought that, okay, both are prestigious. It's just that Marie Curie is more competitive, which makes it more prestigious. So that's how I reached Confirm Center, because I had approached my supervisors now who are there, and they were like, okay, let's write a project together, and there is this call which is out, let's apply for that. And then we applied and we got the fellowship, and that's how I'm working there. And the proposal was on using shape memory alloys, which I had already used in my PhD, in smart wearables. So hand exoskeletons, so that's what I'm working on currently.
So, like, this is a trick question, and where you have to like explain. Till all of the things that we have talked about, you have talked about two major things. One is the smart materials, and one is the smart manufacturing. So, if you have to explain both of these terms to somebody who is just new to all of this, so how would you do that?
Okay. So, normal materials, just like normal materials, they don't have any specific qualities. They just stay there. But smart materials is that if, let's say, I give some input to this device, let's say that temperature input or electrical input or a magnetic field, it will behave in a certain manner. This material will not, because it's just plastic. But then there are materials, for example, piezoelectric materials. If you give them current, they're going to vibrate.
Yes.
And that's happening because there is a contraction and expansion going on inside. There are several layers, and then there is charging, discharging, and things like that. So if you attach these materials, let's say, to a surface, that surface is also going to vibrate. So what we do with these materials is that we can actuate various surfaces where vibration is required. So that is one type of a material. Then there are electroactive polymers, which if you give current, they are going to take a certain shape. Again, there is an ionizing and deionizing going on in the process. And then there are, for example, shape memory alloys, which if you heat, if you give them temperature input, they are going to change their shape. So there is a process involved, how you train them to take that shape, but there is a phase transformation in the lattice structure which is going on, which causes a change in the shape. So there are many such materials. If you actuate them through electricity, through temperature, through magnetic field, they will behave in a certain manner. And then my professor at IIT Kanpur, Dr. Bishak Bhattacharya, he has NPTEL courses on smart materials. And it's a very basic course that you can take, and it's very easy, very simple course for first year BTech student. They can also take and understand that. So you can also take it without taking the exam, just for the awareness part. It's on YouTube. You can, just go on YouTube, look for that. I also was a teaching assistant for that course. So I know that it's a very simple and very easy to understand course. So those are smart materials. Then smart manufacturing is a little different. So have you heard of Industry 4.0? Yes. So when you talk about Industry 4.0, you talk about involving humans and robots and all the collaborative techniques in the manufacturing arenas. So that's what smart manufacturing is, that the manufacturing line, let's say, it's able to take its own decision that, okay, is this part good? Is this part bad? Should I throw it away? So human involvement is reduced. It is there, but it is in a more smart manner. It is only to supervise things. It's not directly using. So there is a lot of reinforced learning and artificial intelligence involved. That's what smart manufacturing is. So when we say smart manufacturing pilot line, we are saying that, okay, everything is being done not automatically, completely, but to an extent. That's what smart manufacturing is. There are more robots involved and more artificial intelligence involved, vision systems to for image processing. Then there are robotic pick and place arms, things like that. Not just that, but it goes beyond that, but it's just a basic idea of what it is.
Okay. So currently your work is being on smart wearables, right? You have been working for quite a bit time. So personally, what is your vision about smart wearables? Where you see this thing going further?
Two fields majorly, because there are many ways in which people are saying that, okay, it can also be used here and there, but it's not very sustainable. It's not a long time solution. But there are two fields where they could really revolutionize. One is medical technology. So for rehabilitation processes, for people who are unable to use their arm to exercise, and not only exercise, to use the other arm, let's say, so exoskeletons. So in medical technology, and the other one is in VR. So in virtual reality, you can use haptic gloves and interact with the environment. But again, in VR, it has to be, gaming is fine. I mean, it's not important or crucial. It's okay. But then there are many learning techniques for people with autism where VR environment is being used to make them more socially aware, or other learning techniques to cope the various constraints that they have in their learning processes. So in that case, VR environments, and also for smart industries. So there are virtual industries where you can interact with the machines without exactly being there. And it could be a blessing if you think about, let's say, I hope not, but let's say there are other pandemics or endemics. So in those situations where you have to have social distancing and you have to still work in a factory or in an environment where you have to socially distance, VR-based industries could be the future, and VR-based learning is very important, and then medical technology. So these are the three fields where I really think, actually two fields, but where I really think that wearables could be really beneficial for mankind.
That's great. That's great. So you initially like belong to Kanpur in UP, and now you're in Ireland. So how that journey has been from Kanpur to you to Ireland?
Okay, I am from, originally I'm from Faizabad. Right now we
Okay.
are living in Lucknow. Yes. But
Okay.
yes, you can say, I do consider Kanpur as my second home. So yes, you can say that.
Hmm.
The journey has been quite smooth. I don't know why, but it has been really smooth in the sense that before settling there, I did have experiences in conferences and workshops. So I had been alone to US for a conference. I was there for 15 days. Then for the Sakura Fellowship, and then I had another conference in Greece, and I had a talk in Prague. So I did travel, fortunately, because my supervisor and the fundings that I was receiving by the government. So yeah, so that is the reason I was aware of the environment outside. And there are many aspects. It's just not the difference between labs. It's also about where can I buy food, what kind of food will be available for me, which I can sustain on, because we have a very different, culturally different food from them. What kind of a language, what accent, can I understand that, can I communicate, how can I use the conveyance services like local buses, local trains, things like that. So all of that, because of these experiences, small bits of experiences, it was a relatively smoother transition from Kanpur to Ireland. The only hard part was the finding a place to live, because it's very hard outside to find a place. It's very easy in India to find places to live. And the good part is that you find Indian stores everywhere. Any small town, anywhere, there is an Indian store. You get your masalas, you make your thing. So it's the good part. The only thing that I miss from Kanpur is the hardworking students. So there is no comparison. Culturally, we are much hardworking. People won't understand because people everywhere work hard in their scale. So for them, hard work is different. For us, hard work is completely different. For us, what they're doing into 10 is what hard work is. So yes, so that's the only thing that I miss. And by hardworking, I mean people who are always, like this, but people who are involved, people who are very much focused and determined, people who dream. So there's so many startups going on in India. There's so many students and, graduates with visions like you, who are building things, who are making things, who want to do more apart from their research, apart from their jobs. So this I miss sometimes. There are people who are doing these things, but the population of such people is less as compared to in India. Here, almost everyone is as motivated as they could be. So that's one thing that I miss. And that's one transition I'm still trying to perfect on. Rest is smooth.
So coming on to the last question of this podcast is, like, if you meet somebody who is about to start his PhD or postdoc, uh, what message will you give to that person?
That is a tough question.
Okay.
If someone is going to start their PhD, I will ask them to think again. I mean, really think. Don't think that, okay, everyone is doing, like my colleagues are doing PhD, so I have to do a PhD, or my parents are telling me to do a PhD, I should do a PhD. Or PhD would be fun, I will do groundbreaking research, I'll win a Nobel Prize during my PhD. No, that doesn't happen. So if you're really interested in becoming a professor, if you like to teach, if you like to engage with people, if you like to speak, that's when you should really consider doing PhD. If your aim is to go into research, there are other ways as well to go into research, even after masters. Don't need a PhD for that. But still, if you want to go through a PhD for your research, it's fine. But your focus should either be research or teaching. And you should be interested in both. It shouldn't just be the easy way out. Because PhD, once you get in, it is not an easy way out. It does seem that, okay, you will get 5 years of education, you will get paid for it. So, and the pay is okay. I mean, it's good enough to sustain. And you will have, libraries and other facilities that you can make use of. It's a very fancy idea, but the journey is not as fancy. It's very tough actually, both physically and emotionally. So the reward, the reward, which is the degree, is very, what to say, rewarding, but the process is not as easy. So if someone is going to start their PhD, do think about it twice, because I have seen many people with, uh, with sleepless nights, with a lot of pressure, with yes, with imposter
Same here,
syndrome.
same here, same here.
Yes, yes, there are so many things that go on, and that's why we are discussing these things. So it's not an easy way out. It never is. PhD is never. It could be from a UPTU college. It could be from ISC Bangalore. It doesn't matter. It is always going to be a tough journey. So think again. And then if you have thought about it and you are certain that stop talking, I'm going to join. So it's okay. But then you have to think about your topic. Your topic should be relevant to the field. If you're working on the fundamentals, it's good. If you're interested, it's good. But the projects that are funded are the projects that are currently in trend. And by that, I mean, what are the requirements right now? Or what are the requirements for 5 years from now, 10 years from now? So you have to choose a topic which is relevant right now. Fundamentals is also good. I mean, if you're interested in doing basic maths, basic science, it's good. So those are just the two suggestions I will give. Think if you really want to do PhD, and if you are motivated, think of a topic. Don't just take a topic, what your supervisor sees. Do this. Don't think about it, because you have to live with that topic for 5 years, and you have to talk about that topic for your entire life. So you have to think about that topic if it really makes you happy and excited to talk about. If it doesn't, it doesn't make sense. So
So somebody on the road just thought of starting a big machine and create a noise. So with this we'll bring this podcast to the end because there's so much noise. Plus, but I'm really thankful that you gave me time, and and for me personally, I felt so good to talk to you because when we talk to somebody, we come to know about so many things, and this has been a knowledgeable podcast for me especially, and I hope for the audience also, but for me also. So thank you so much for coming. Thank you so much for giving us the time, and I'm really thankful for this.
thank you for having me. And I really hope that you guys who are listening to this can find some bits and pieces which could help you in your research. And if there are any doubts, you can send it to him, Chandan, or I have my website, which you can also send me doubts on. I'll be happy to engage. Thank you.